This is going to be a two-part problem. So part one, we actually calculate this improper integral to determine if it converges or diverges. And part two, we use the fact that this converges or diverges to prove that another integral converges or diverges using comparison test. So let's first use the limit definition to determine where this converges or diverges. So if I start off the integral from 1 to infinity of 1 over x dx, that's equal to the limit as b goes to infinity of 1 to b 1 over x dx. That's always the first thing that you should do when you're doing an improper integral, is put the limit in front, always. That's equal to, now since I'm not taking the limit yet, I still have to write it. You don't actually take the limit until after you've used the fundamental theorem. But the integral of 1 over x is the natural log of the absolute value of x, and that's going to go from 1 to b. Now, since these values here from 1 to b are all positive, the next step I don't have to have the absolute value. So that's going to be the limit as b goes to infinity of, using the fundamental theorem, the natural log of b minus the natural log of 1. Okay, the natural log of 1, you should know, is 0. Just know that. You're not allowed to use a calculator in the gateway. For those of you in my class, just know the natural log of 1 is 0. Why? Because the power needed on e to get 1 is 0. E to the 0 equals 1. Therefore, that equals 0. This is a double arrow, by the way, if you're wondering. Can't really see it. There we go. So in this problem, then, I have, continuing on with that thought, I need to take the limit as b goes to infinity of just the natural log of b, because this is 0. So as b gets larger and larger and larger and larger, what happens to the natural log of the larger values? Well, they actually get larger too. Just think about the graph for a second. Natural log of b goes through here, moves up, and it doesn't have a horizontal asymptote up here at all. It just keeps increasing, increasing, increasing as b gets larger. So that means that this limit goes to infinity. Don't say it equals infinity, because infinity is not a number. You can also say it does not exist. But what does the improper integral then do? Does it converge or diverge? Well, because the limit doesn't exist, we say the integral diverges.